Hello everybody, I hope you are all feeling good, and I have turned myself into, can you get what this is? It is a coffee bean, because I don't think I would have reached this far with the recordings without coffee, and I probably think that you have drunk a fair bit of coffee during this 165 experience yourself. So this is the last topic. Are you excited? I am. Okay, I'm just going to turn myself back to normal now, even though I kind of like being a coffee bean. I like my tan. Okay, I'm back to normal now. So here are our learning objectives for this last topic of 165. I can't believe it. Okay, the lymphatic system. It is normally coloured in green in your textbooks. And as you can see in the picture, it works alongside the circulatory system. So you've got your blood vessels, but the lymphatic system works together with those blood vessels, and they play a very, very important role. Okay, so they drain the fluid, remember? Remember when we did capillary exchange and we lose fluid when we're at the arterial end? We suck the fluid back in, we're at the venous end, and the rest of it is picked up by the lymphatic system. So we need it. It's our drain. The other thing that we need the lymphatic system for is because a lot of our white blood cells for our immune system live in the lymphatic system. So the lymphatic system is made up of 3 parts. It's the lymphatic vessels, which are just like blood vessels, but they work alongside the blood vessels. We have lymphatic tissue, and we're going to go through all of those, how they all work. And then we have lymph, which is the fluid inside the lymphatic vessels. Okay, so I did kind of talk about this a little bit before. So collects fluid, returns it to the veins. Our cells of our immune system live there, and I'm going to show you where they live. And the other thing that you probably didn't know about is that the lymphatic system is involved in transporting fat. And we're going to look at that later. So don't worry too much about that now. We can look at it later in 175 when we finish 165 and we recover from all the coffee that we have been drinking. Right, we've seen this before. So this is not new. You lose arterial end, lose fluid, suck it back in here, and the excess goes out in the lymphatic system. So we've seen this before. Happy days. This is what your beautiful little lymphatic capillaries look like. Aren't they cute? Look, you've got your artery end, you've got your venous end, and this is the capillary bed. Remember, the capillary bed is pretty much where we directly interface with cells. It's business end. Can you see the lymphatic capillaries are in amongst that? Okay, so they pick up that excess fluid. So they work alongside the capillaries. So what is lymph? So interstitial fluid, when it goes into the little lymphatic capillary, then it's called lymph, pretty much. It's a little bit different to plasma, but it's a lot like interstitial fluid. Here is another picture. Look at the cells all living in your tissue, all happy. Artery, vein, lymphatic system. So just a little bit more on the little lymphatic capillaries because they are so cute. So the fluid, the interstitial fluid, enter through the flaps. Yeah. See these cells? That guy there? So they make up the capillary and they're like little gaps, see? And the fluid goes in the little gaps. They're super cute. Right. Now, the lymphatic system is, you have lymphatic blood vessels, lymphatic vessels everywhere. Okay? They're there from the entire body. So they are there like all throughout your body. However, the fluid that they drain is not symmetrical. So for example, and I'm going to show you in a minute a picture. Can you see this green area here? So all the fluid that we pick up in that green area goes into there. All right? Now have a look at the pink part. All the fluid that we pick up, the interstitial fluid, the lymph that we pick up, ends up there. Yeah? So it's tiny little spot there. You can see it. See there and there? So it's not symmetrical. Much of our things in our body is not symmetrical, and this is just another example. So we have the little capillaries, and then they make bigger vessels, and then they make trunks, and then we've got these big collecting ducts, which we saw just now. So this is a really good picture to show you how it kind of works. You've got the little capillaries. Now, when we are collecting lymph through the vessels and into the trunks, we go through nodes, lymph nodes. And then we end up in the trunks and then in the ducts and in the ducts. Oh, I can't speak today, honestly. I can't get my words out. I'm getting my turds wangled, which means words tangled. Okay, so here we go. And then we end up in the systemic circulation, which is in the veins. Okay, in the venous system, in the veins. Right. So, actually, I think we might push on. Let's push on. That's what I say. Okay, so we had a look at the vessels and we had a look at lymph. Now we're going to look at lymphatic tissue. Right, so the most numerous of the lymphatic organs would have to be the lymph nodes, and they are beautiful little kidney bean shaped little things, and they are very, very useful. Look, you have so many lymph nodes around all parts of your body, okay? Lots and lots and lots of lymph nodes. Now what they do is, since you're collecting stuff here, fluid, so lymph is being collected, it's making its way up, goes through the lymph node, and then ends up here. lymph node is super duper useful. Let's have a look and see how it works. So lymph comes in through here and then eventually goes back out the top, right? So it's in here, back out the top. As it goes through the lymph node, what happens is that you have cells, white blood cells, looking through your lymph. Now, what I suggest you to do is that you watch this lecture, then you watch the lectures for immunity, which are the next two parts, and then you come back and watch this again because it'll make more sense to you. So you've got these dendritic cells, so white blood cells are there, and they go around your lymph and make sure and clean it up and get rid of things. So you've got dendritic cells that live there. You've got B cells that live there and T cells. And then we end up going out this way. Okay, so do this part, then do the next two, and then come back to this. Right, so how the hell do we get lymph from our foot all the way up to our veins? Well, exactly the same way that we get blood all the way up there. Lymphatic vessels contract. Lymphatic vessels have valves. We have skeletal muscle pump. We saw this before. We saw the thoracic pump as well. Okay? So exercise increases your lymphatic return. You know, if you've got blood flow in a vein, it sucks it in as well. Okay? So the same way that we got blood back to the heart is kind of used to get lymph back to the vein. All right, let's have a look at tonsils. Some of you may have had your tonsils out. So can you see here that you've got tonsils? Tonsils are just lymphatic tissue. And what it actually has white blood cells there ready to attack any foreign pathogen that needs to be killed. So it's designed to protect you, okay? Protect against bacteria around your nose and your mouth. If you want to have a look at more details on the structure of tonsils, just click on that link. But that is what tonsils are. Now, lymphatic tissue really is just a collection of white blood cells living in a certain spot, okay, fundamentally. So we have white blood cell bases around our body in case we need them at that location. And this is one white blood cell base. The thymus. The thymus is another type of lymphatic tissue, and I don't think actually we really know what it does. We just know that it's involved in white blood cells, so immunity. And have a look and see where it sits, just on top of the heart, okay? And here are some kind of cells that kind of live there. Now, I'll leave you to watch this little video here that I have about the thymus to learn a little bit more about what its job is. The spleen. Wow, I love the spleen. It is a very cool organ. Here it is, okay? It's got blood coming in and blood coming out, and of course, lymphatic drainage. Now let's have a look and see how the spleen works. It is super cool. So we have areas here, right, in the spleen. Can you see how you've got red pulp and white pulp? Well, white pulp is just a whole bunch of white blood cells. So what happens is that you got blood coming in, okay, and then the blood is let loose in the spleen. Yeah? So the blood comes in through the artery and it's let loose. And so the white blood cells in the spleen are killing anything that needs to be killed in the blood. So it's looking over, white blood cells are doing quality control over the blood. And then the blood comes back out again. How cool is that? Very, very cool. Oh, and here is another repeated slide. So clearly I'm losing my mind. Okay, what is lymphedema? Lymphedema is when you have an accumulation of fluid, all right? So this means that your lymph nodes are not doing what they're supposed to be doing. You're losing your drain, okay? And it's not good and it looks so painful. So let's have a look and see what's happening at the tissue bed. What is producing this, what looks to be a very uncomfortable and painful condition? Here is what happens normally. So you've got your cells living in the capillary bed, happy days. Fluid is moves from the blood vessel to the interstitial space, and then at this end it gets sucked back in and the remainder goes through here through the lymphatic capillary. This is what should be happening. So at the end of the day, the amount of fluid that goes in is the amount of fluid that comes back out again. Whereas if you don't have the lymphatic system, then you're losing this little drain here, and so fluid starts to build up. So here we go, and that means that this poor little guy here, look at his access to blood. He's not getting really the access that he used to have to the bloodstream, and that's what causes the swelling, and the cells aren't happy because they don't like to be squashed, and they want to also be, have access to the blood supply. So because this increases the diffusion distance, right? Diffusion distance. And that's it. Yay!